Galaxies cannot live forever. Like humans, galaxies age over billions of years until they eventually fade away when star formation ceases. We will explore the sad, gradual demise of galaxies and the processes that accelerate death. Buckle up for this somber journey into the final days of galactic life while we await a little surprise at the end. Section 1. What is a galaxy? A galaxy is an enormous collection of gas, dust, and billions of stars bound together by gravity. The familiar Milky Way in which we reside spans 100,000 light-years across, with over 200 billion stars swirling in a flattened disk. Galaxies also contain dark matter, providing extra gravitational glue, and supermassive black holes lurking at their centers. Our cosmic cities come in spiral, elliptical, and irregular shapes based on their structure. While diverse, all galaxies emerge, evolve, and eventually perish over vast eons of time. Section 2. Galaxy life cycles. After the Big Bang, slight density fluctuations in primordial gas clouds became gravitationally unstable. These patches collapsed under their own weight, spinning up protogalaxies that gave birth to the first stars. The cycle continued as gas cooled and condensed into new generations of stars. Galaxies grow by assimilating nearby gas and by merging together in violent collisions. Over billions of years, galaxies use up their gas reservoirs needed to spawn stars and morph in shape as explosive outbursts alter structure. Eventually, most activity ceases, leaving behind inert collections of aging stars and compact remnants. Section 3. Galactic cannibalism. In the cosmic web of filaments and voids, galaxies cluster together with the largest dominate their surroundings. The immense gravity of giant galaxies can rip apart and dissolve smaller neighbors in a process called tidal disruption. Streams of stars get sucked out and captured, their gas providing fresh stellar nurseries. This galactic cannibalism helps big galaxies grow ever larger, while removing the very building blocks for small galaxies to thrive. Mergers can also trigger bursts of new star formation, using up any remaining gas more quickly and accelerating a galaxy's demise. Section 4. Galactic collisions. Galaxies frequently crash into one another as they drift through intergalactic space. These slow-motion collisions can dramatically alter their appearance over hundreds of millions of years. Direct hits can distort spiral structure or puff up disks into football-shaped ellipsoids. The incoming galaxy also donates stars and gas to the merger remnant, providing new material for star formation. Multiple major mergers can complete morph a spiral galaxy into an elliptical, but the violence ultimately exhausts gas reserves, leaving behind a swollen, dead relic devoid of stellar nurseries. Section 5. Loss of gas. For stars to form, ample raw material in the form of gas must be available to gravitationally collapse into stellar embryos. But over billions of years, various mechanisms in galaxies can blow, use up, or strip away this critical ingredient. Supernova explosions launch gas into intergalactic space. Active black holes energetically heat gas so that it escapes galaxies altogether. And in clusters, galaxies feel the brunt of stripping forces that tear gas directly from their disks. With gas tanks drained over time, star formation sputters out, accelerating the march toward extinction. Section 6. Stellar mass loss. The stars within galaxies also contribute to their eventual demise. Stars convert hydrogen and helium into heavier elements over their lifetimes. In the final stages, aging stars unleash fierce stellar winds, blowing off over half their mass in giant clouds of gas and dust. The expelled ingredients contain less hydrogen needed for new stars. As generations of stars die, the increasingly metal-rich interstellar material becomes too scarce and enriched to readily collapse and form new suns. Like inheritance lost to the void, stellar mass loss robs galaxies of self-renewal. Section 7. Supernovae explosions. The spectacular deaths of the most massive stars, supernovae, also sow the seeds of galaxy destruction. In their final moments, massive stars shed their envelopes violently before exploding with the power of billions of suns. These titanic blasts generate hot bubbles of gas that swell out at millions of miles per hour. Repeated supernovae can work together to create powerful winds that rob entire galaxies of their gas. With fuel exhausted, the stellar nurseries shut down, leaving aging stars to fade quietly toward oblivion. Section 8. Black holes. Lurking at the heart of most large galaxies are supermassive black holes up to 1 billion times the sun's mass. Quiet for much of their lives, these beasts episodically snack on stars and gas clouds that pass too close to their gaping maws. During intense active galactic nuclei phases, infalling matter cranks up the black hole into an energetic engine, spewing jets and radiation. This violent feedback can heat surrounding gas, launch powerful winds, and halt nearby star birth. By belching away the raw materials for next-gen stars, central black holes help darken galaxies on the path to retirement. We have traced the unhappy trajectory of galactic evolution as our star-filled cities slowly darken over eons. Through processes like gas stripping, stellar mass loss, mergers, and feedback from supernovae and black holes, galaxies' guys exhaust the very resources needed to manufacture new suns. Bereft of stellar nurseries, the emerging museum relics continue gliding as graveyards of stars until perhaps their lights go out forever. But amidst the gloom, there yet remains one last avenue that may briefly delay a galaxy's inevitable demise. We appreciate you joining us on this sobering galactic journey. If you would like to see the little surprise about one way galaxies can temporarily avoid death's cold grasp, please subscribe as we unpack this gleam of hope in the next video. As always, we value each thumbs up and your comments. Please share if you know others who love the astonishing world of astronomy. Now gaze up at the stars, pondering the fleeting nature of even the grandest cosmic structures. Until next time, signing off from the space between stars.